So welcome to the Node.js Node API team meeting for June 2nd, 2023. We'll follow our standard approach of looking at what is tagged for milestone 11. Before we get started, anybody have any announcements or news they'd like to share?
Yeah, we've just landed the Node API version 9.
Okay, that's great news.
Yeah.
Do you want to
Awesome.
add that in the issue that's for new news?
Yes, definitely. It's a big good news to the Node API.
Yeah. Do you want to add it as a post there? Or do you want me to
Yeah,
take
I
a
can do
note
it.
either way? So, okay. Yeah, if you can go and do that,
Yeah.
that would be good. Okay. Great. Any other news that people want to share? Okay, if not, I'm going to share my screen. So in terms of driving towards full coverage, Jack let us know that he wasn't able to make that today. I think there was a one last test that he was adding. I'm not sure where that pull request is. Right. So I think that's this one. And I guess Kevin and Jack have been going back and forth. So that's just progressing. Probably nothing to chat about. Adding the list of non-C language bindings. I know Nicola, who also let us know he couldn't make it this week, is working away at that. So I think that's ongoing. Haven't done anything on the enabling testing for debugging, for add-ons. We already talked about this one, the improve the scoring in the OpenSS scorecard. I still have to get back to look at the issue in terms of what's failing. So that takes us down to stale issues, I think. Okay. So this one, we added some comments about the next steps on that. I assume that's still underway.
Yes, I kind of started to work on this implementation, but I didn't finish before today's meeting.
Yeah, no,
So
it sounds like a bigger effort for
I'm
sure.
working on this set immediate stuff, and I have a question.
Yep.
I see like today inside of node.js, we have two flavors of set immediate. One of them set immediate, and another one set immediate thread safe. I kind of I really like idea to expose them both. What do you think?
What's the difference like when it says thread safe?
Honestly, you cannot access the UV loop or UV handle on the other threads. So the thread safe set immediate is make it possible to call set immediate on another thread.
Right. So that's if you're like a thread other than the main thread loop.
Right.
I think it would be overlapping with the thread safe function in terms of the thread safety, right?
Yeah, it sounds to me like it's a one-shot thread safe function.
Right. It will be kind of simplest way to do thread safe function. Yes.
Yeah.
But you're saying like in terms of what's the of exposing both of them. So we're in the finalizer. And so like, because I think if I understand it, and I could have this wrong, is like we're in the C finalizer, which is now going to be a pure finalizer.
Right.
And you want to run some JavaScript code. So you need to call something. And it seems to me you'd either be in one of those two situations, like you'll always be on the main thread, or you'll always be off the main thread. So is there a case where it's going to be different between like where you'd want to use one versus the other? I guess that's my question is like, when would you want to use one versus when would you want to use the other one?
Oh, I don't understand. Why would you ever be off the main thread in a finalizer?
Yeah, it's guaranteed that our finalizer code on the main thread.
Yeah.
Yeah, my question was mostly around like, yes, set immediate will suffice. I just do we want to also have a set immediate thread safe, not related to finalizers. Kind of like one shot thread safe function, simplified version, if you like.
I see. So you mean just like in Node API itself? Because this will go into the node part, not the not right, because it's node specific.
No, it will go inside of a JS native API.
So set immediate should go inside JS native API because it is absolutely necessary, right?
Right.
But thread safe set immediate should not, because it is not strictly required for supporting the engine, right? And other implementations may or may not have this. So like set immediate in implementations where it's always safe to call the finalizer, to call into JS from the finalizer is trivial, right? For those that it is not, well, they're going to have to figure out something just as we do, right? But they probably also have an event loop and they can use the same implementation. But for thread safe, I don't see why that should be required for implementing the spec, right? Because JS native API is for the spec, right? So I'm okay-ish with putting it in Node. I mean, thread safe function is in Node, right? It's not in JS native API, if I remember correctly. So and this is a simplified version of that. So I think it can go in Node. I mean, if we see demand from other engines, we can consider moving it. But I don't see why it should go into JS native API.
Just will make a lot of interesting scenarios more possible. Let's say it's okay. Like we can do it later. Like just as a kind of looking at this stuff, like we think like, well, why not to have them both? But yeah, we can add it later.
What scenarios did you have in mind, just out of curiosity?
Like for example, if you're using this, pretty much what these thread safe functions can be used today, but in this case, it will be available for the core. So whenever people want to use Node API from different thread, with set immediate thread safe would be kind of the mechanism to go, right?
Oh, I see. So, okay, I think I see one difference that is kind of important. With thread safe function, you have to create a thing and then use it from a different thread, right? Whereas here, you don't have to create anything. You can just use a Lambda and that's it. Right.
Yeah, you just simply say, oh, I'd like to kind of submit to this kind of looper, like. Yeah, like.
Oh, okay. So you could pass persistent references to another thread, and then it would kind of be like an API make callback, except it would be like an API make thread safe callback, and then you could do it. One thing about it, if you did this in a tight loop, let's say the background thread called the set immediate like over and over, then because it is stateless, right? Every call is a call unto itself, and you'd want to guarantee at least one call on the main thread. Then for each invocation of set immediate thread safe, you would have to create a handle, like a UV async handle, because UV async is called at least once, right? So if you did this in a tight loop, then you would be creating a lot of UV async handles, right? So for those scenarios, you couldn't really use it. So this would be like for those that occasionally call the main thread, right? Because otherwise you should use a thread safe function, because that's only a single handle. Well, it uses other resources, but at least the number of resources is constant with respect to the number of calls.
Right.
So yeah, I mean, I'm not fundamentally opposed to exposing it, but is this like a solution looking for a problem? Do we have native add-ons that would really like this? So
sorry, but I may not follow the discussion. I'm afraid I still have difficulties to understand the use case that thread safe function cannot be used here.
it
Why
can.
thread safe function?
This thread safe set immediate is not a fundamental resource that makes things possible that otherwise would not be possible, right? Because yes, you can use thread safe function, but the idea here is that you don't have to create like a thread safe function as a separate object. If you have an NAPI reference to the function you want to call, that is sufficient, right? And then you say, and then instead of like NAPI make callback, you say like NAPI make thread safe callback, and that function can be called from any thread. Unlike NAPI make callback, which can only be called from the main thread. And so you only need the reference. You don't need the reference wrapped into like an NAPI thread safe function. That's the difference. The downside is that the number of handles would be linear in the number of calls. And there would be a race, right? If you make the call very often, then the number of handles in the loop would build up. So you'd have to be careful how often you call it. You'd have to sort of, well, throttle it somehow. And that we don't have a mechanism for that without the thread safe function.
So I think I understand, but it definitely is like, I would keep it as a separate discussion / trade work from doing the one we need within the finalizer, because it is kind of definitely a different context. The other thing is I don't know that I'd thought of like, hey, this basically set immediate that you could call it anywhere, right? Like as part of the API versus just within the finalizers. I don't know that there's any concern with that, but I thought I'd see if anybody else can think of any reasons why we wouldn't want to have that as just a general function.
I don't know that we could render it as like a finalizer specific function, right?
Yeah, that might be a challenge too. But the first question is like, is there even a concern? If there's no concern, well then,
no, I don't see a concern.
Right? So, no,
I'm not concerned about this at all, because the whether you call it from a finalizer or not, it will execute whatever its body is at the next tick when the engine is guaranteed to be in a state that it's able to execute JavaScript. Now, whether that is a call from JavaScript or not, it doesn't matter. The engine is able to execute JavaScript. The novel functionality that it provides, without which finalizers that have to call into JavaScript are impossible, is to be able to be called at a time when the engine cannot execute JavaScript. That is the real value that it provides.
right.
If as a side effect it also provides some other value, then so be it. That's how I look at it.
And the what was I thinking? Just that was the other thing, just as a sanity check, like all engines should be able to implement, like any JavaScript engine should have the concept of running something in the next.
I think so, because JavaScript execution sooner or later returns control to the engine itself, right? Oh, and sooner or later control returns to the thing that invoked the engine to begin with. I mean, it has to, right? Otherwise, the JavaScript execution never terminates. So like, which may be fine, but as far as I know, JavaScript isn't very useful on its own, right? Like if you just stay inside JavaScript forever, then sooner or later you can't do anything in the real world. Correct me if I'm wrong.
Yeah, especially kind of some promises, some other kind of asynchronous behavior.
That's right. That's right. You can't even do promises without going back to native. Good point.
Right, but I guess is it like, so our distinction between Java? So that's one. Okay, so that sounds like the yes. The other question was like, the distinction between our JS native API and the Node API headers are things like usually the JS native one API should be things that are in the the ECMAScript that map to something in the ECMAScript spec.
Yeah, that's a fair point, right? So yet there are things that are not in the spec that are unique to being an interface between the spec, essentially as represented by the engine, and the native world. Like the spec never talks about references either, right? Like persistent references, other than, you know, for garbage collection purposes. And so I would argue that, so I would say that the argument for putting set immediate into JS native API is the fact that it is an artifact of interacting with the engine, because as we have learned, some engines may not support JavaScript execution during garbage collection, and therefore, if we want to continue doing that so as to remain backwards compatible with what we have now, and at the same time solve the problem of accumulating objects because they have native references, we have no choice but to do this. And we're not doing this because it's a node-specific thing. Well, it is a node-specific thing. It's a V8-specific thing, right? And so this is kind of V8 influencing the direction of JS native API, which is okay as long as it doesn't make it impossible to follow that direction by everybody else. That's how
I guess one way to look at it too is, are the references, are basically the APIs to set up the references that end up causing this callback in JS native API? If yes, then this should be in the same API. So
yeah, definitely. I mean, so I mean the existence of references causes calls to finalizers. That much is certain. But the necessity to execute JavaScript from a finalizer is something that is present, and it is a call into the engine, right? Any engine, you know. So like, for example, buffers are clearly a node specific thing. No other engine nor environment supports buffers except maybe to sort of emulate Node, right? The same thing with thread safe function. It's not, you know, nobody in ECMA talks about whether calling a JavaScript function should be thread safe or not, because JavaScript per se doesn't have the concept of threads, right? Workers are sort of, they're outside the spec in the sense that it is they take the entire spec and copy it over and over and over, right? So that's why I think that this should go into JS native API.
I posted a link in the chat. It's in the ECMA 262. It defines a host hooks, which is used for queuing a finalization registry, cleaning up callback. So it's required by the spec that a implementation of JavaScript needs to be aware, needs to be able to queue up a callback when a object is being finalized, and it's a part of the JavaScript API. So I think the ability should be supported by modern engines. The problem here is that, is the name appropriate for all implementations to is the name set immediate appropriate, or do we need a rename to make it more generic to the JavaScript engine? So
that I think is a good point. Like, I don't think it should be. Go ahead.
Yeah, I mean, set immediate is the node thing. It never goes into any specification. So in order to align it with the engine or other JavaScript, renaming might be a good approach to make it more generic.
Yeah, I think something like a run JavaScript when possible or something like that. Right, because that's really what we want is like, if it's not possible now, run it when it is possible. And the set immediate is one implementation, but like if another engine can actually run JavaScript in the finalizer, it could just run it immediately, right?
Yeah.
Yeah.
So yeah, we can define that as the callback queued by the node API set immediate can be called at an arbitrary time when the engine think it is safe to execute JavaScript.
Yeah, I think this is a great way to phrase the documentation, because you know, if that is immediate and synchronous, then an implementation can feel free to call this synchronously. But if that is not possible, as is the case with V8, then you know, it cannot be called synchronously. And so the user of this new API should expect that you know, the JavaScript may or may not execute synchronously, and we already have stuff like that. I think we have instances where you pass a call, like on the JavaScript side, where you pass a callback, and sometimes it's synchronous, sometimes it's not. I think NS lookup is like that, right? Like DNS.lookup. If you pass it a host name, then it will, you know, give you back a promise, etc., etc. And then when the network call completes, then you have yourself your IP. Yay! But if you pass in an IP, then the callback that you passed in gets called before the call to lookup even returns. In other words, synchronously. So
I think that's another point. I don't remember the name correctly, but I think there is a principle that we should never, in the Node.js core, that we should never call the callback limit synchronously. And even it is, we know that the result is complete right away, we must call it in the next tick. I'm not sure if I can recall the principle.
I think in set immediate, or like that's probably the case, right? Like there's ones where you're like you in particular don't want it to run immediately. You want it to run. So set immediate, I think, is not just defer it because I can't run it now. It's like defer it because I don't want it to run now. So that's why I'm thinking like a naming difference. If what we want is really just run it when you can, that's not set immediate in terms of the name.
So it sounds like we need to have at least async in the name. So I think we make it obvious it must be a synchronous call.
Well, if we want to force it to be asynchronous, like would we want to prevent, like in this particular use case, do we want to prevent it from running, say for a JavaScript engine in your finalizers, they can run JavaScript. Do we want to prevent an engine from just running it immediately?
We do. We really want to kind of make sure it runs in the next tick, right? Like the function should be explicitly mean that any implementers of this function must run it as a next tick.
But why is a next tick, right? Like we've got a pure finalizer because it's not going to, I guess we've said the pure finalizer isn't going to run any JavaScript. I guess that's what we're saying. Okay.
Right.
So in which case it does need to be right. Is the question that's if it's called in the finalizer, it could be called some other time.
Right.
But
we can name it, for
yeah,
example.
no, I get, yeah. Okay.
We can name it, for example, Node API run job async. We pretty much want to execute some job asynchronously.
Right, and then the async says
yeah,
it can run it anytime and later on kind of thing.
Or probably can be like a name like post task or in queue task anyway, which is much more similar to the in queue micro task or the Viet platform post task.
So it will be like in queue task, or post task.
Yeah, that's a alternative.
Yeah, sounds great to me too. So we'll use. Are we using in queue term somewhere?
We'd have to look if there might be some on the thread safe.
Okay, I'll check which terms we use in thread safe. So
Yeah,
it's
it's for thread safe. For thread safe, it's just call. So that's it. So we don't have in queue the idea for thread safe is that to make it look like an API call function. Yeah, it's an API call thread safe function. So it's trying to be as close to an API call function as possible.
Okay, I guess like question which verb it's more preferable because I'm not native English speaker. Post or in queue.
I think for me, NQ works a little bit better. So like in Q, sort of Q JavaScript or NQ JavaScript.
No, it will be not JavaScript string. We'll have effectively some kind of callback with some additional data passed in. So technically, the signature of this function will have effectively two callbacks. It will have a callback to invoke the job, and another callback to finalize it. Because with each job, we can provide some data, and the point then we need to destroy it, we need to call finalizer. And finalizer will have pretty much also finalizer hint.
Why can't the invoked function perform the finalization? So you allocate in the finalizer for the persistent reference, and you free in the immediately called callback.
I was doing a lot of asynchronous in Office, and we also need to account for the cases, and the job cannot be queued. Like ideally, I don't know if we're gonna have such situations here.
So if you need a queue, then the event loop is a bad candidate, right? Because the event loop is precious. You don't want to burden it with asynchronous handles. So, we need to come up with another mechanism then. Like the handle count
exactly the same functionality is set immediately. We just it just behaves. We're just coming up with different name. I don't see what's changed.
Right. Actually, now that I think about it, right? What are we trying to achieve here? Like we're trying to. Okay. Like. Okay, I think I know what the problem is. Okay, implementation wise, I just realized that we cannot just use, or can we use? Okay, we're going to use node.js set immediate, right? And so we're not actually going to touch the event loop, right? But
yeah.
Is node.js set immediate appropriate for the job, right? Because the reason I ask is that is it currently used for finalizing, for making calls into JavaScript and from like other finalizers outside of Node API, like inside Node.js itself? Is it used for that purpose? Because I'm not sure how it's implemented, but if there is one handle for each invocation, then that's bad.
The way set immediate works, like they have some kind of vector or like queue. Effectively, they have, I think it's single linked list or something like this. But no matter, there is some kind of collection. So
Okay.
then every time you send set immediate, what's happening, like we're just adding something to this collection, and then this collection being processed in batches. Like
Okay, so okay, but what resource are we using from the event loop? Is it like an idle handle? And so basically idle handle with a callback that says, fetch n number of things from the collection and execute them and then return. And then next time there's an idle, next time the event loop is idle, continue until the collection is empty and then remove the handle. Is that the implementation?
No, the way I saw it, it actually tries to complete everything inside of its list, at least
Okay.
for whatever like non-thread safe set immediate tasks.
Okay, yeah. Okay, I see. Okay, but so there's a single handle for the entire collection. Okay, that's fine then. Okay,
Right.
never mind. Yeah, thank you for clarifying that.
How about a name like schedule JavaScript?
But wait a minute. We don't want to schedule JavaScript. We want to schedule a native callback to run, right?
Okay, so we're scheduling a
Yeah.
native callback, which is going to be able to run JavaScript, right?
Yes.
It may,
So it's really run
it-
when JavaScript capable, right?
Yeah.
yeah, and the function can be called with a JavaScript, right? So the function can be exposed to JavaScript, even though I don't see why it is needed, but it can be called from the JavaScript. So yeah, and the callback may not call JavaScript.
So
So do we that can call into JavaScript flag? Like, is it something where it could be like we check that, and if the answer is no, then we schedule it for later, otherwise we run it immediately?
The problem with the can call JavaScript flag is that we didn't intercept all the Viet disallow JavaScript scope. So flag currently only is being set when the node environment is being shut down. So
Okay.
in the scope of a finalizer, the flag isn't being set, so it's not possible to I'm not sure how it behaves. Maybe it currently just simply crash. I'm not sure the current behavior, but yeah, the flag isn't being set when we call the finalizer.
Okay, so the answer is no today. At some point, maybe we could optimize that, but like if it's basically like it's like run when JavaScript capable is kind of like, and you're giving it a native function, right? So it's saying run this native function when when you're allowed to run JavaScript, right?
Yeah, I just realized one thing, and maybe you guys have already talked about this. So if we split execution into portions that cannot execute JavaScript and portions that can, we are complicating the process of finalization because we need to pass data from the portion that cannot execute JavaScript to the portion that can. Vladimir, you pointed out that we're going to have like a finalizer for the finalizer kind of thing. So that is super duper complicated. And so I'm wondering, might it not be better to just specify, like add a flag per reference that says, execute immediately or execute in a deferred way. And then we save ourselves this entire complication. So, and we could solve this with the single API that takes an NAPI reference or an NAPI wrapped object if you don't have a reference. and it just sets this flag.
But
So
you have a finalizer which is being called with a like some parameters, right? Which have the data that you're going to be. If you just pass that on to this other function.
yeah, so you're not actually finalizing anything.
No, it like basically, I think the model is that by default things now become pure.
Yeah.
So if you are pure, you just like you don't have to do anything. If you are non-pure, then the simplest case is you just wrap what you had in your existing finalizer into something that you call in the finalizer using this method.
Yeah, I get that. But do you see the complication? You have to create two callbacks. You have to provide two callbacks if you're non-pure. Right? You have to provide the pure finalizer, and then
Sure.
you have to write a second function that gets called from this API when JavaScript is ready.
Right, but that should just, so basically you have to write a wrapper which calls the say you've got the existing code, you would hopefully just call a wrapper, write a wrapper function and stick it in between.
Yeah, I get that. But okay, so that's that is not so complicated. But then inside your finalizer, you can also create a new piece of data that you pass to this, whatever we're going to call this API, right? And then if unless you do, as I was saying earlier, which is you allocate this piece of data inside your finalizer and you deallocate it inside this JavaScript safe finalizer, then, and Vladimir, I think you were saying this, you need a finalizer for this data, right? So
yeah, I think that's I kind of was start to work with kind of set immediate generic functions. I was started thinking with generic terms. But you're right. If we inside of finalizer call, finalizer effectively has two parameters, right? Like has data plus finalizer hint.
Yeah.
And ideally, we should, if we implement not generic function but specialized function, what we need to do, we need to have some kind of signature which accepts both parameters, like data and finalizer hint, right?
So I mean,
yeah, it maybe should be the same signature.
Yeah. So I mean, it sounds like those add-ons that need to finalize using JavaScript will, like 99.7 sigma of the time, they will simply have one line of code in their finalizer, which is this new API, comma, callback, comma, data, comma, hint, done. That's what it looks like. So they're just gonna wrap this every time and not do anything else in their pure finalizer. So
right, we need at least optimize for this case.
I'm sorry, what do you mean by this case?
Like for this, like what you just said. People, I think what they care, they want to, they don't want, their finalizer is not pure. So we need to show them effectively, you just, inside of your current finalizer, you just need to call another function and pass exactly the same parameters as your previous finalizer used to have.
Yeah, but I mean, it's not a requirement though. That's the thing. They can do whatever they want, right? As long as they understand that, I mean, and people understand that memory management is up to them. It's just, okay. So I mean, okay, we can do it this way, right? I'm good with that.
Yeah, and I think our thinking is this is more the exception, right? Like,
yeah,
pure finalizers are going to be the most common case. It's worth optimizing for that. That's why making them the default and actually having to have people, when they opt into the next Node API version, have to do something. If it's as simple as adding like a one-liner, wrapper, that also makes it good, right? In that it's not something that you have to think too much about, easy to do, right?
Yeah. And on the C++ side, we could potentially do this inside Node add-on API, right? Like we could simply provide this wrapper for them so they can just write directly the JavaScript safe finalizer, right? Because it could be as simple as a Lambda.
Right. Yeah, that's when we were talking, I was thinking maybe that's possible, like some sort of C++ sugar
Yeah,
that says, like there's a new thing called, anyway, maybe that would be possible, but
yeah. I think we could solve like this flag idea. Is this reference pure, or does this reference have a pure finalizer or not? That flag we could do in C++ and implement it using these two callbacks, and then in C, as has been traditional with Node API, you have finer grained control, whereas in C++ you have this convenience of just saying, just run my finalizer. And by the way, it's a JavaScript one. The specification of which is now required, meaning you have to say, is this a pure finalizer or not? But you can still do it the same way. And you're going to be making code changes anyway to opt into this. So I think that's pretty good.
as long as the default is like, we still
Yes,
want
yes.
people to
yeah.
just by default get the new behavior, because that's the whole premise is
Right.
people
Yes,
need
yes.
that, and that's where we get the value of actually forcing a change in the first place.
Yep. That's going to bubble up into Node add-on API.
Yeah.
All right, cool.
Okay, so let's see, stale issues. This one was, I think, Gabriel, you were working on a test.
Yeah,
that-
I'm waiting on on a release of Node add-on API.
Okay,
Because like I want this crash prevention to be in there.
okay, so let me just put a note in there so that like next week we remember. Today, waiting on release of Node add-on API. Okay. So that'll be like we were discussing. Kevin was looking at I'm not quite sure how far he got, but he was looking at doing a major release to drop Node 14 support anyway, so we should get that. Okay. And then this one is just a samples, and I know, Vladimir, I think you've been busy on other things, so that's probably okay. So we're down to 10 minutes, so quickly let's flip over to the two, just see if there's any issues or PRs we should talk about.
This is API stable.
Yeah, okay. No, that.
There is one issue. I looked at it recently. 1174 in this repo.
Okay, 1174. This one, right?
So I ran, like I tried to run some of the commands in there, and so they gave a repro here. The branch, okay, the PR number 72 on their repo is being recommended as an illustration of the crash.
Right. Okay.
But since then, that PR has been merged. So yesterday, I checked out the main branch in that repo, and I ran those commands, and they don't crash for me. So I don't know if anybody else has any context on that. If not, I'll just comment to that effect.
I don't think so. Probably it would make sense, yeah, if you just want to comment to that effect. And
Okay.
okay. This one's brand new, so I think we can leave till next week. Safe property accessors. Okay, so that's a fairly new one that we maybe just need to take a look at. Otherwise, are there any others that people want us to discuss? No, I'm going over here. No, that's not what I wanted. And I don't want to be an issue. This one, yeah, I think that version matrix,
Yeah, I just filed this so that we don't forget.
yeah, makes sense. I'm thinking that we should probably even just think of like an alternate way of maintaining that matrix or something, just because it's like,
Yeah,
especially with the backports and stuff, it's kind of difficult to maintain.
Yeah, the matrix doesn't work well with the release process with the replace me tag.
Yeah,
Since we cannot place the replace me tag everywhere in the matrix, it will be released. It will be. I mean, yeah, it is hard to get two of this work well.
yeah. I don't know. So we can think, maybe spend some time thinking about what that should be. In the worst case, yeah, we can update it just this one time to make sure it's valid. So this one, I don't know if anybody's seen, there has been some discussion. Okay. I guess, Gabriel, you've been involved. Anything you think that's worth discussing or mentioning?
Oh, yeah, this one. No, I think there's a fundamental problem with implementing this. That was my last comment. Like normally it would be great, but the way the V8 API is implemented is it takes a parameter to this storage thing, the resource or whatever it's called, and so I don't know that we can implement this generically, because if the V8 API does not accept the static string directly, then we need to maintain an object that ultimately just provides the static string when required. But we would have to create a reference to that. We would have to create a reference to the string, which we now can, and then we'd have to deallocate that. No, sorry, not a reference to the string. We'd have to create a reference to this structure, which ultimately provides the static string, and then we'd have to a weak reference, and then we'd have to delete that reference along with the string. And so I'm not sure if that is worth it for us, because like the implementation would be super complicated, right? So yeah. If V8 and the example that is given here from Rust is one where Rust creates a static structure that can then be given to V8, which makes sense, but which cannot cross the API stable boundary, right? Like for Rust, it works because they declare the structure statically, and the size of the structure is known at compile time, and it works for the time for that version of V8 against which it is being compiled at the time. But there is no structure that we can define and store on the side of the add-on, which happens to be a valid structure that we can pass to V8. And keep passing it to V8 like 5 years from now. Because the definition of this intermediate structure may change on the V8 side, and then we have to worry about, oh boy, is this like a version 1 or version 2 of the structure, and so yeah, I don't.
Right. Okay. So the benefit comes from the fact that you're passing, like not making a copy, right?
The benefit is the fact that you don't need to copy the string when you create it. That's my understanding. I'm not sure if subsequent accesses are also improved as a result.
So, but you're saying like a 1 byte string and a 2 byte string, those are not standard things.
So it whatever they are, it works, and I understand why it works. Is you're saving yourself a copy. You're not copying the string into the engine. You're just referring. It's like an external buffer, but
Right,
for strings,
yeah.
right? The problem is that with an external buffer, it is expected that there is some kind of memory management, right? And here, the memory management is supposed to be provided by this intermediate structure, right? Where you can the structure has members like get the data or get the cached data, and there's supposed to be a distinction. So if you can open the v8 string new external 2-byte, like the reference to that, just I don't know, you can probably find it on node source where they have like the v8 reference. I don't think there's a link here, but if you just copy v8 string new external 1-byte into Google, you should find it very quickly. So yeah, that's what I found so far.
Right. Yeah, I'm just thinking like if there was a method that's like, yeah, create string, create external string.
It's very similar, as Gabriel said, to creating external buffers. We also have a limitation with external buffers. I remember this the whole caging
Right.
discussion, like V8 caging. Like for example, it will be not applicable in Electron, for example.
Yeah, exactly. Yeah, it may. Yeah. So
I think that's
it's
probably the best rationale I could think of.
I raised that point, and I got an answer on that. Let me just double check.
But I see one scenario when it will be extremely useful. We do have today something like run script. A run script expects an API value which is string. So in order to run JavaScript, like we can imagine I have like 6 megabytes JavaScript, right?
Yeah.
So first of all, I need to convert the string into V8 string, and only after that I can run. And many engines, they can have shortcuts to run your script from the string, right? It's probably the only kind of scenario where I think which these external strings will be extremely useful.
Yeah,
There's
yeah.
lots and lots of strings which are just constants in your C code, right?
Right.
Yeah.
So like I can definitely see that aspect of like in your, say your C code, you just got these constants, you define it with the quotes, and avoiding a copy for those is potentially interesting. Then the longer they are, the more interesting, right?
Yeah, exactly. Yeah. It doesn't make sense for short strings because so like I said, because there's this intermediate, and actually I pasted the API reference into the chat. So if you could please open the page, that would be really helpful.
Sure.
Because I can show you why we need all this complication just to create a string.
Where's my chat? Sorry.
Yeah, no worries.
Find that. Where is that? Is it not? Oh, here it is. Okay. Here, right?
Oh, I'm sorry. Sorry, I was muted. You need to go a little bit lower to the publics okay, static public. Here we go.
Right.
Yeah. So if you look at new external 2-byte and new external 1-byte, you need this external string resource star, right? Yeah, click on it. Yeah, it's even clearer. It emphasizes it. Yeah, so you need this external string resource star, right? This is not something we can store on the add-on side of things because this structure may change over time. So my thinking is that in order to implement this, we accept the static string from the user and we accept its length. And so we create the structure in the implementation of that API, and then we create the V8 string, and we create a weak reference to the string that is responsible for freeing the structure. And we know it's going to be a pure finalizer because, well, we control it, right? So we don't have this issue of arbitrary code and JavaScript execution and all that.
The external string resource, what is that? Like, is that
yeah, click on it. You'll see it's a full-fledged class with members that are being called by the engine and all that. So see, it has like, it returns the void const the data. It has a length, and it has cached data, and it has update data cache.
right?
So,
Is it like you have to create a new one for every time you do this, or is it one that's used across your app?
well, the contents, like this, logically and conceptually, an instance of this class wraps a specific string. So you have to return different values for different strings. So the easiest way to do that is to create one instance per string, meaning heap allocated.
Okay, so it's something. It's not it's not something that like we create once and put in the end. It's like you've got to create a whole new thing.
99.9% of users of this API would do exactly that, because they control both sides. They control the engine side and they control the call side, right? But we don't. So we can't do that. We have to heap allocate this when the string is incoming from the add-on, right? We cannot put something in the add-on that is the equivalent of this structure, because that's not ABI stable, right? We're kind of leaking the implementation at that point. And yes, we could do a generic implementation, but then we'd have things like, okay, we'd have to allocate the structure statically on the add-on side, and then the size in bytes of that structure would somehow be at least as big as the size of this external resource thingy. And then what if external resource thingy gets bigger later? Then we'll have to heap allocate anyway, so we might as well just heap allocate from the start.
So, but this external resource, string resource, so you're saying like you create, what's the constructor look like of that?
It has no constructor.
I think it's a kind of class you probably, it's actually abstract class you need to inherit.
Yeah, you probably subclass it, yeah.
Because you see it's abstract functions, data and length, the abstract methods.
Yeah.
And I think
I guess I'm still not like, if to use this new 1 byte from, so you got new.
No, you want external, right? The new from 1 byte we already have.
Right, okay, where's the external?
Above it, immediately
Okay.
above it. Here.
Right, so this new 1 byte external. I see, so you have to create this thing which wraps the string itself.
Yeah, exactly.
And then you must pass the string into it somehow, right?
Yeah, you subclass it and then you pass the string in. So the subclass constructor takes one parameter, which is the string and the length, and then you pass it, you cast it as a superclass and you pass it into VA.
Right, okay, so it's not an abstract thing, you have to do it for your particular instance, okay.
Yeah.
And the documentation says like base class has dispose method, right? So technically we need to somehow allocate this thing, and inside probably on dispose method we can release this resource, right?
Yep. Yes. Yes, that's right. But we still need to know when to destroy the instance itself, right? Which is why we need the weak reference.
But shouldn't like this, if I create this external, shouldn't there still something be on the heap that, is basically, instead of contains the bytes, has a pointer to the bytes?
Oh, yeah. Oh, absolutely. The benefit is still there, right?
But that should be cleaned up itself, I'm thinking, right? Like once there's no longer references to the string, just like a regular string, it should be able to clean up the.
I don't think the engine will not do that though, right? Because the engine receives a pointer to the structure. Okay, well, no, it may do that. I'm not sure. We need to figure that out. Like the engine receives a pointer to a class, to an instance of a class, right? When the string goes out of scope in JavaScript, does it call delete on this pointer? I actually don't think so, because the pointer could have been allocated with any memory management.
No, but it should never delete the pointer. Like, I think the API could be like, when you say new from this, it's like, it could be like the case that we're talking about, like it never gets deleted. It's not that you've done a new one, and it's like it's in your binary. Like those static strings, they don't ever get deleted, so you don't need to delete them.
Oh, yeah. Yes, yes. This would happen. This would, yes. Normally, what you would do. So if you are not Node API, if you are somebody who, like, if you are Node itself, right? What you would do is you would declare you have a global static string inside Node, right? Then you would declare a global static instance of this external 1-byte string resource subclass and pass it your other global static string, right? And then you would pass a pointer to this global static instance to V8, and now everything's hunky-dory. And it would never get deleted because it's global static, just like the string never gets deleted because it's global static, right?
But I guess, like, I'm trying to, like, I'm thinking of, why wouldn't it work like a regular object that once you no longer, like, instead of passing in a string that gets copied into the heap, you pass it a pointer and tell it this data is never going to go away. So you just create a thing on the heap which points, like, has a reference to that pointer. But you still want to do garbage collection, because, like, if you're no longer using that string, you'd want the element in the heap to get collected, even if you're not going to collect what it points to, because you say the thing that it points to is never going to go away, right?
Oh, yeah. So the element on the heap, you're talking about the instance of this external 1-byte string resource?
Yeah.
Oh, definitely. Yeah. So that's
I don't see the problem, right? Like, okay, we create, we you call this method, it adds something to the heap. As long as the thing on the heap gets created, I don't see managing the lifespan of the string being an issue. It should be like the API would have to say the pointer to the string. You can only use this only give us pointers to strings that will never be collected. They're just static, right?
Yeah.
Then I still think it comes back to your other concern of, well, okay, what if pointer cage doesn't allow that? Then but that might be then a fallback, right? Like, you're basically saying, hey, I'm creating a string from a static, optimize if you want. And in cases where you can optimize, we can say, oh yeah, V8 has a particular case. Yes, we can do that. If pointer cage is enabled, nope, just call our regular string creation effectively, right?
Yes. And the same thing for Electron, right? Like you
right, like
go back to just copying the string.
We would just say, if pointer cage is enabled, don't optimize, like, just fall through.
But isn't I'm not familiar with pointer cage, but is it not smart enough to understand that the pointer to the string is global static, and therefore it doesn't need to be accounted for when the process ends?
No, the issue with pointer cage is that you may have a pointer to something that is outside the range that is accessible. Same with the external buffer, right? Like, you've got a pointer, and in C code, it's perfectly valid because you've got 64-bit address space. The problem is that you can't store a reference to that in the heap, because the heap only allows you to reference things within some more limited range. And so the same thing could happen here. You could have a string, it's static, but that pointer isn't within the range of the cage, and therefore it can't just use that pointer.
But this allows anything that's stored in the binary itself and mapped at load time. So any global static stuff is disallowed by the cage, then, not just strings and buffers and stuff.
Yeah, I mean, it's possible that it's disallowed. And that's why we're like, we could say basically if cage is enabled, like I think the suggestion here is the application can provide more information and the engine could optimize. So like, and this is a case where like in Vladimir's case, it's like, hey, I'm passing you a static and it's 6 gig or 6 meg. It does seem like that little bit of extra information is useful, right? So it's basically we're saying we'll give you some extra information. If you can't use that information, then it should just fall back to a regular string creation, which would copy and put it in. If you can do something smart, then do that smart thing.
But how do we decide whether we can or cannot? Like, how do we implement this pointer cage awareness in the Node API?
There's a define.
Oh,
Like
so this is
it's basically a static, like you either build with it or build without it. So regular Node doesn't have pointer cage enabled, but Electron has decided to turn it on.
Oh, I see. Oh, okay. So this is something. Okay, this is something we'd have to do. Okay, I see. And it's too late to do this for buffer because we already have API guarantees that external buffer will work, and so we have like a runtime. We have chosen to do a runtime error message saying, if pointer cage is enabled, then you attempt to create an external buffer and it returns cannot create external buffer instead of returning an API. Okay, I see. Okay, so that's historically, but here we have an opportunity to do something better than that. And because this is a new API, and so what we will do is if def this thing is on, then basically just fall back to regular string creation and just call the other an API for creating a plain old Latin 1 string, or if it's a 2-byte, then the other one. Okay, yeah, okay, I get that. Yeah, we can do that. That's
yeah,
no problem.
I think I'm trying to remember why we didn't have the built-in automatic fallback, but there was some reason with the APIs why that just didn't work for external, I think.
I think it's because it was already out there, and so the memory management was there were already add-ons doing memory management based on whether it was an external or not. So it was for stability, I think.
I think the issue is that like when you say external, you believe you can potentially change that memory and have it affect the buffer. Like you have a pointer, right? And so you expect to be able to change the code there. So just silently making a copy doesn't work because you're expecting you can modify the external buffer. Whereas these strings, we could define an API that very clearly says it's a static, it has to be a static string.
Yes.
And never be deleted, right? And
yes,
provided you give us a pointer to something that's static and never be deleted, then whether we make a copy of it or not really doesn't matter.
You're right. Yes, it works in the case of strings. Yes.
So that's
strings are immutable in that sense.
Yeah, exactly. Because strings are, we can constrain it to say you point us to a piece of memory. We can say basically you have to consider that it's immutable once you pass it into us. Otherwise, you're breaking the
I mean, and it is immutable because there is quite simply no way to write to a string in JavaScript. There just isn't.
Yeah, but in C, so the thing is, we're talking about a C pointer. So I could allocate a C pointer, I could pass it into this thing, and actually, if I change it, it will now change what the string it seems.
Yeah, it looks like in JavaScript.
Right, but we will have to make the API specifically disallow that, and like if it may happen to work, but if you do that, you're doing something wrong.
Yeah. I think we can solve that in documentation. Yeah, like don't rely on this being passed on because it is possible that it will create a copy under certain circumstances.
Yeah.
That's definitely one to document. Okay, let me write all these points down.
So that's where it kind of can, if it can be, that it seems like it's a case where we could say it's like giving us an extra hint, like this is static, it will never move. And then we can say like the implement, and I think there's some cases like Vladimir just pointed out, if it's a big enough string, that really is a help. So maybe it is worthwhile.
Yeah.
And the default implementation for any engine that doesn't have it is to just create a copy.
Yep. Yep. And for an engine that does have it, also create a copy if this pointer changes on.
Well,
So-
yeah, that's effectively, yes, like if it's a case where like a pointer to an existing string may not be accessible, then yeah, just create a copy as well.
Okay. Okay. Why don't I try to take a stab at this implementation and then we can thrash this out in the PR?
Sounds good.
All right, cool.
There's only one caveat I would like to ask about this 1 byte stuff. I like Hermes engine, for example, does not support Latin 1. They either support ASCII strings or they support UTF-16. So I wonder if we can replace Latin 1 with ASCII requirements, and which is actually much easier to check, right? Because all ASCII characters must be seven bits.
I think, yes, okay, so. Right, that's a very good
How's it
point.
deal
Like,
with existing? Because
what
I
we're
think we already
taking-
have Latin 1 node APIs. How does Hermes deal with those?
I pretty much map it to ASCII, like, or if I need to convert it effectively to UTF-8 if I see any non-ASCII characters.
Okay, then can you reuse this mechanism for this particular one? Well, no, you can't because the string is already, the string is static, right? You can't, right? You can't change the string.
Yeah, but you also have a point that if we can't use your buffer, we can copy. So technically, yeah, you're right. It's no big deal. Yes.
Yeah,
It should
yeah,
just
yeah,
be,
exactly.
you would copy, you would call the exact same, like your existing method.
Yeah.
With
Yeah,
Latin
yeah,
1, I
exactly. And
guess,
you have
right?
no guarantees that it will be optimized. It'll just be like a best effort. And in the case of Hermes, this effort will be that much bigger and therefore that much less likely that it will be optimized. If you start using weird characters inside your string, then sorry. That's basically Hermes' answer, correct?
Right. Okay.
And I guess,
Right.
maybe we shouldn't use the 1 byte string and 2 byte string name. We should use something which maps to.
Oh, yeah. We already have these. Like we have an API create string UTF-8, sorry, not UTF-8, Latin 1, and we have an API create string UTF-16, I think, or multi-byte or something like that.
Yeah, we use
So-
UTF-16. We're actually, let's be very explicit about encoding.
Right.
Yeah, exactly. So I'm suggesting that the naming would be exactly the same as create string, except it'll be create external string.
Right. It'd be
And-
variants of the ones we already have.
Yes, exactly. Yes.
And
We're not going to
inside of
introduce any
them-
new names.
The default implementation can just call the other one.
Exactly. That's right. Yes.
And
Okay.
V8 does not support for UTF-8. So technically, should we have only Latin 1 and UTF-16, or we support all
So, well,
three?
we can add them later. And the funny thing is, if somebody from another Node API implementation shows up at this meeting and says, "Hey, can I have a UTF-8 version of this?" We'll be like, "Well, okay," and then we'll just implement it by falling back, and UTF-8 will never be optimized; it'll always be copied. So we'll be in Hermes' shoes at that point.
I think we should almost, why wouldn't we just do them all with some being fallbacks? Like if we think this is a useful
good point.
concept, then
Yeah.
I would just say it's either like, yes, it's worthwhile, or no, it isn't. So you can write your code to give us the hint and we'll either use it or not.
Yeah. Okay. Yeah. So okay. So then the UTF-8 implementation is in effect like an alias for plain create string for now, and that will become evident, as soon as it hits the streets, so to speak.
It's
Yeah.
not optimized, but if V8 at some point provides us something that it could be optimized, it makes sense.
Yeah.
It's,
Yes.
if some other engine wants to implement it, they can implement it, because
Yeah.
the argument could be, say, well, don't do it if it's not being optimized, but then like other engines would have the same argument, like your people are calling this and it's not optimized on my engine, so
Yeah. Okay, that's good.
Okay.
Okay.
Any other things, we're a bit over time, but any other ones we should talk about this week instead of deferring to next week?
I'm okay with deferring.
Okay, so yeah, let's close out. Thanks for everybody's time, and we'll see everybody in GitHub in next time.
Yep. Talk to y'all later. Bye.
Thanks. Bye.
Bye.